just like the mean was not always a great measure for skewed data or data with outliers, the standard deviation is not a good measurement for that same type of sample where you had outliers or skewed data. So we need to have another way of describing the spread of our distribution. And what that value is related to our median. So remember, the median was the middle value of our data set. It represents where you have 50% of the data below and 50% of the data above. Well, we're just going to take that just a little bit further, and instead of splitting our data into halves, we're going to split it into fourths. So we'll have this bottom 25% of our data, and that's going to be cut off by what's called the first or the lower quartile. And you'll see that typically written as a capital Q with a 1 or an L. And it's really just the median of the lower half of the observations. Then our second quartile, which is now the 50% marker, well, that's just the median. Now, sometimes it is written Q2, but it is just our median. The third or the upper quartile, that's going to now be where we're at that 75% mark, 3/4, and that's notated with a Q3 or a QU, and it's really just the median of the upper half of the observations. So we find those quartiles, and then we have this new value for measuring our variability, and that's this interquartile range. It gives us the middle 50% of the observations. So it's not the standard deviation, but it is still kind of giving us what the middle range of our values would be. And that helps us get a sense of kind of what is there in the middle or the typical values in our distribution. It's a very simple thing to calculate. You take Q3, you subtract Q1, and that gives you this IQR or interquartile range. But the thing to remember here is it is the middle 50%. The median is going to split your data into two halves, but what we're really looking at is for the IQR, we're looking at the middle 50%. So from the median down a quarter and the median up a quarter. So you can think of the quartiles in this illustration where you have the bottom 25%, and that's marked with your Q1. You have your median, which is another 25%, then your Q3 with another 25%, and then your upper values. When we talk about our summary statistics for this kind of distribution, we'll also include the minimum value and the maximum value for 5 numbers that just tell us how our data is split up into quarters. So how do we actually calculate these? Well, of course, we can get them in JUMP relatively easily. They are one of the default summary statistics. But the way that we can calculate this, if we wanted to do it by hand, is first you would find the lower quartile. So first you have to figure out which location your first quartile is going to be in. And you simply take 1/4 of n, whatever the sample size is. Because remember, we want a quarter of our sample size. If that's a whole number, then you're going to look at the D and the D+1 location and find the mean there. So you'll add those two values and divide by 2. If your D1 is not a whole number, so if you get a decimal here, then just round up the number you get, and that's the position of Q1. So let me show you how to get the other quartiles, and then we'll show an example. To find Q3, you do 3/4 of n, because we're here at the upper 75th, so 3/4. If it's a whole number, you're going to do that value and the next one, divide by 2 to get the mean. If it's not a whole number, then you round up and it's just that single value. Let's look at example 3.10, where we're looking at some pulse rates. So here we have 10 observations of different resting pulse rates for patients in an exercise study. Let's find Q1, the median, and Q3, as well as the interquartile range. The first thing that you have to do is order your data. It needs to go from least to greatest, so we'll find our smallest number and just continue until we have ordered all of the values in our data set. And I always end up missing one, so I have to, sometimes you'll actually see me, kind of marking these off, but even then, I sometimes will just miss one. So I always count at the end. You can see I missed 64. It's hard to do this and talk. So there's 64. Right now, 66, 68, 71, which is 72, 73, and a 76. And I'll count, make sure I did get all 10, and it looks like we're good to go here. Now, the Q1 is going to be, well, let's find the median first. So we've already done finding the median for others, but this is going to be at your n over 2 spot, which in this case we have 10 over 2, which is 5. And so remember, if you get a whole number, then you have to do that value and the next one and find the average. So we'll do the 1, 2, 3, 4, 5, and 6 location, 66 plus 68, and divide that by 2. So here our median is 67. To get Q1, we'll do 1/4 of our sample size of 10. So 1/4 of 10 is 2.5, so we'll round to the third. And so here we don't have to do anything other than say it is 62. And to find Q3, we do 3/4 of our sample size. And when you do that, you get 7.5, but we don't use decimals, we will round up to the 8th. And so the 8th value here is 72, and we don't have to average any of them. So if you ever get a whole number with these, then you do need to go from that value and the next one and average. But if you get a decimal, just round up, and that's the one that you'll use. So our Q1 is 62, our Q3 is 72, and so to get the IQR, it is simply the upper quartile minus the lower quartile, or 72 minus 62, which gives us 10. Now we can do this easily in JUMP, so let me show you where to go on that. We've already seen it, but let me just point out where it is. Not sure why this data file has 30 observations. These are all just missing, so it really only has 10 observations, but I'm not sure why it was labeled all the way to 30, but don't worry about it. We have our 10 resting pulse rates. So when I analyze the distribution, when I pull this over, it knows that these are numerical, and so it's going to give me my numerical summaries. And you can notice here that you've got quartile, median, quartile. The lower one is the 25, the upper one is the 75. However, I can get this up here or down here in the summary statistics if I wanted to. So click on the red arrow and customize summary statistics, and you can add your interquartile range, and I don't think that we can add Q1 and Q3, but they're already there. So if you want to add the interquartile range, then you can add it right there and say okay, and now the interquartile range is showing up. But I do want to point out that the quartile that you're getting in JUMP and the quartile that we got in our doing this by hand is slightly different. It turns out that there are at least 4 different ways to calculate quartiles. And the method that we're using in the textbook is Tukey's method, and this method is one that doesn't require quite as much math. You're able to do it just by looking at an ordered set of data. The method that they're using in JUMP is a little more precise, it is a little more accurate, but it's not going to be the answer that they're looking for in your homework. So while the excuse me, while the quartiles that you see here in JUMP are actually the better answer, it's not the answer that you do in an introductory statistics course. So I know that that's one thing that you'll not be able to use JUMP to do automatically, but we can still do this because the calculations are not that difficult to do. So what I would recommend that you do is you'll need to sort your data. Not particularly difficult. All you do is right click and you go sort, and I would do sort ascending so it goes from least to greatest. It will open up in a new table, and you'll see all of those zeros that were in there was kind of problematic. But it just opened in a new table because it couldn't just replace it. But now we have our sorted data, and here we've got 1, 2, 3, 4, 5, 6, 7, and so on. So if we had just typed this in ourselves, I don't think those dots would have been in this data set. I'm not sure why they're there for this particular file, but on your homework, hopefully they won't be the little dots, and you'll just have from 1 to 10. But anyway, we've got from 1 to 10, and we can do that formula 1/4 of n, 1/2 of n, 3/4 of n, and get our answers that way. So you still would see I need to look at the 5th and 6th position to average to get the median. I need to look at the 3rd position for Q1 and the 8th position for Q2. And depending on the sample size, you would do that for your values. So I apologize that you can't just use the value, or at least I don't think you can just use the value from JUMP when you are typing in your homework, but it might accept both answers. So I'm imagining that it's only going to accept where you figured out those positions using the 2-key method, and not with the interpolation method that JUMP is using.